Hello friends, I am Professor Yashpal Khedkar. Welcome you in the video lecture of unit number 2, different load curves and load factors. In this video lecture, we are going to discuss the introduction of the different load curves and load factors in detail. Let us start. A power station, which is also referred to as a power plant and sometimes generating station or generating plant, is an industrial facility for the generation of electrical power. Power stations are generally connected to an grid, which is known as the electrical grid also, for the proper transmission of the electricity to the distribution system, means the load center. The electricity produced or electricity consumed is known as the load, and from that we can develop the concept of load curve. The load curve is the curve which is showing the variation of the load on the power station with respect to time. So here one load curve is provided over there. From 12 midnight, means from 12 am to the once again the 12 pm, means almost 24 hours in a day, we have covered on the x axis of this graph. We have put it on the x axis of this graph after the equal interval of the 2 hours each, and on y axis we have provided the load on the power plant or load on the grid. So here the load is mentioned in the megawatt, or sometime it can be mentioned in the kilowatt, and the time factor in the of the day we have provided on the x axis. That time factor may be the week, that time factor may be the annual month or years also. And here on x axis the load can be expressed in the watt, kilowatt or megawatt also. The power demands of the different consumers vary in accordance with their activities, and these activities are related with the time. Means during the morning up to 10 am the power requirement is more, because people are getting ready to do their daily work, and power after midnight is going to be get almost reduced, because people are not running any kind of the electrical equipment or appliances during that night time. So there the load demand is also going to be get decreased. The result of such a variation in demand is that load on the power station is never constant, rather it varies from time to time. The daily load curve is presented over here, and we have seen the different variations in the power requirement through that particular curve. From 12 midnight to that 7 am almost, the load demand is increasing. After 7 am to the 12 noon, the load demand is going to start, or it is decrease. After 12 noon it is going to increase up to 1 pm, and once again there is a small slack in the load demand. After that up to 6 to 7 pm the energy demand is increased, and after that it is decreasing very fast. So that variation we can record on the graph of time spent versus the load on the power grid, and that particular curve which will be formed after locating the graph is known as the load curve. according to the different time span and the loads utilized during that time span, loads are having its various types, that daily load, monthly load, annual load, domestic load, commercial load, industrial load. Specially, two types of the technical terms are included as far as load is going to be concerned, and that is the base load and the peak load. When the load is considered for a day, that will be known as the day load. When load will be considered for the month, that will be known as a monthly load. When load is considered for the 1 year, it will be called as annual load. When load we are using for our to run the home appliances and electrical equipment, that is known as the domestic load. In the commercial sector, the load utilized is known as the commercial load, and at industry, the energy or electricity utilized is known as the industrial load. But the unvarying load, which occurs almost the whole day on the station, which is almost constant during whole daytime, is known as the base load, while the peak load is the according to the various peak demands of the load of the station. Based on these loads, there are certain types of the load curves, which are daily load curves, monthly load curves, yearly or annual load curves, load duration curves, and integrated load curves. Importance of the daily load curve. The daily load curves have attained a great importance in a generation as they supply the following information readily. The daily load curve show the variation of the load on the power station during different hours of the day. Means at morning 5 to 6 hours how much load is required, at afternoon how much load is there on the power plant, in the evening time how much load is there, and at night time how much load is on the load center on the power plant. The area under the daily load curve gives the number of units generated in a day or consumed in a day. The unit generated per day is equal to area in kilowatt hour under daily load curve. The highest point on the daily load curve represents the maximum demand on the station of the day. The area under the daily load curve divided by the total number of hours given the average gives the average load on the station in the day. So this is the first formula to calculate the average load on the daily load curve is area in kilowatt hour under daily load curve divided by 24 hours will provide us the average load on the power station. Means for 1 hour almost how much load is going to be there on the power station, it can be explained, it can be calculated by using the formula which is given in front of you. The ratio of the area under the load curve to the total area of rectangle in which it is contained gives the load factor. The load curve helps in selecting the size and number of generating units. That part is very much important, and we are going to discuss this particular point, the size and number of generating units, in the further or in the next chapter. So load curve is also helping to the consultant to decide the size and number of generating units. According to the load demand, we are designing the size and the number of generating units in the power plant. The load curve helps in preparing the operation schedule of the station. Means how much generating unit we will have to start, that particular part will be decided by taking a look of the load curves. At the same time, load curves gives us idea about the increment in the demand for the future also. So that's why study and recording and the study of the load curve is very much important. So load factor is given by the formula average load divided by maximum demand. When we will multiply average load to the by 24 and maximum demand by 24, then the load factor of the day can be decided. The average load is nothing but the area in kilowatt under the daily load curve by 24 and the total area of the rectangle in which load is contained. That particular ratio also can give us the load factor. Now, after studying the load curve, we can concentrate on the next concept, that is load duration curve. There are some facts about load duration curve, and it can be summarized as the load duration curve is arranged of all load levels in descending order of its magnitude. The area under the load duration curve represents the energy demanded by the system. It can be used in economic dispatching, system planning, and reliability evaluation. This load duration curve is more convenient to deal with it than the load curve. So here the load curve and load duration curve of the same day consuming same load during 24 hours is provided. So here we can see that load curve is drawn according to the demand or according to the load consumed or the load on the power station, and here in a load duration curve the same amount of the load has been drafted, but it is in descending order. So here first of all the maximum load for the 8 hours is taken into consideration. Then next load we have taken for almost 4 hours into consideration, and for remaining 12 hours the lowest load we have taken into consideration. If you will calculate the load by utilizing load curve and load duration curve, it will provide the same magnitude, because the difference is only that in load duration curve we are drafting the curve only in the descending order, but load demand is not going to change in the load duration curve as compared to the load curve. So here the load duration curve is provided where the loads are drafted in the descending order. The highest amount of the loads here we can see from almost 78 to the 98, that particular load percent will be considered as the peak load curve. Then up to from this 78 to the 40% load, it has been considered as the intermediate load plants, and the load which has percentage below 40, it will come as the base load power plant. Means up to 40% energy will be provided by the base load power plant. Then up to 78% of the load, from 40 to 78, that particular energy will be provided by the intermediate load plants, and when the demand will reach to the peak load power plants, peak load plants or peak, it will be satisfied, it will be completed with the help of making peak load power plants on. So in this load curve we have compared the difference between load curve of the summer and winter. So red line indicates the load in the summer season and the blue line indicates the load variation in the winter season. We have observed that here the load consumed by the summer is more, and the highest peak point we can observe in the summer days. While we are using some of the electrical equipments or the appliances like a refrigerator, TV, electric pot, desk lamp and others, and air conditioners in our 24 hours in whole day. So here one another load curve has drawn where it can show the base load, intermediate load and peak load demand during the day of the consumer. So refrigerator is on almost 24 hours. So that's why that will be considered as the base load. Then for few hours only we are making television set on. So there is a slightly increment in the load. Then we are using the other equipments like a fan, tube lights, etc. for more time as compared to the television. So it will consume more energy than the television. And air conditioner we are using almost the whole day time and some hours in the evening, and it will consume more load. That's why it will take the use of the air condition at some of the peak levels during the day. So from that it is clear with the help of the load curve we can calculate the load during the day on the power plant. We can draw load curve for the single consumer, for the commercial sector, for the industry, and for each and every customer who is utilizing the electricity to run electrical equipment or the appliances. Now we are going to discuss some of the important definitions which are useful to solve the numericals related with this load factor. The first definition is of the connected load. Connected load is the sum of continuous rating of all the equipments connected to the supply system. For example, we are running the tubes, fans, electrical pot, refrigerator, air conditioner, fans, etc. for our use. When we are making such equipments on, then the sum of the electricity used during that time when we are making all equipments on, or that particular load, is known as connected load. The next definition is of maximum demand. It is the greatest demand of load on the power station during given time period. The third definition is of the demand factor, and demand factor is nothing but the ratio of power station ratio on of the demand on the power station, which is maximum one, to the connected load. Means demand factor is ratio of maximum demand to connected load. The fourth definition is of the average load. The average load occurring on the power plant station is given for the period, day or month or year, is known as the average load or the average demand. And we know that how we can calculate the average load. If we want to calculate the average load for the day, then number of units generated or consumed in a day divided by 24 hours is the formula. If you want to take the average load of the month, then we will have to multiply 24 into 30. If you want to calculate the daily average load, then you will have to take 24 into 365, which is nothing but 8760. The next parameter which we are going to discuss is nothing but the plant use factor. It is the ratio of kilowatt hour generated to the product of plant capacity and the number of hours for which the plant is in operation. So, the formula can be written as a plant use factor is equal to station output in kilowatt hour divided by plant capacity into hours of use. So, one simple problem is given over here to understand how to calculate the plant use factor. Suppose a plant having installed capacity of 20 megawatt produces annual output of 7.35 into 10 raised to 8 kilowatt hour and remains in operation for 2190 hours in year, then plant use factor will be calculated by providing station output in a kilowatt hour, that is 7.35 into 10 raised to 8 divided by 20 into 10 raised to 3. So, here the 20 megawatt, it has been converted into kilowatt because the units, the station output is provided in a kilowatt hours, multiplied by 2190, which are nothing but the operated hours, and that particular ratio is 0.167, which is presented in the form of the percentage 16.7. The units generated per annum is equal to the maximum demand in kilowatt multiplied by load factor into 8760. The 8760 are the hours in a year, and it can be calculated by taking multiplication of 24 hours into 365 days. The next parameter is reserve capacity, and that can be calculated by taking the difference between plant capacity and maximum demand. In other words, we can say that the reserve capacity is nothing but the difference between plant capacity and maximum demand. Types of the loads. Already we have studied this particular bit in the previous one bit, but only we have enlisted it. Now, here we are going to discuss in detail about the types of load. A device which taps electrical energy from the electrical power system is called as a load on the system. The load may be resistive, inductive, capacitive, or combination of them. The various types of the load on the power systems are: number 1, domestic load. As name suggests, domestic load consists of lights, fans, refrigerator, heater, television, small motors for pumping water, etc. Most of the residential load occurs only for some hours during the day, that is 24 hours. For example, lighting load occurs during night time, and domestic appliances load occurs for only a few hours when we are using it. For this reason, the load factor is very low, is of 10% to 12%. The domestic load means the load which is occurred when we are using the electricity to serve the domestic purposes or in our day-to-day life. The second load type is commercial load. Commercial load consists of lighting for shops, fans, electrical appliances used in restaurants, etc. The class of load, the commercial load, has seasonal variation due to the extensive use of air conditioners and the space heaters. Means in a summer we require the air conditioner for more hours, but during winter season we require the space heaters instead of air conditioner. In summer days we require less lighting instruments, but in winter season we require more lighting instruments. So there is a certain variation we can observe in the commercial load. The next type of the load is the industrial load. Industrial load consists of the load demand by industries. The magnitude of industrial load depends upon the type of industry. Thus, small scale industry required load up to 25 kilowatt, medium scale industry between 25 kilowatt to 100 kilowatt, and large scale industry require load above 500 kilowatt. Industrial loads are generally not weather dependent, but yes, they may be the time dependent. The municipal load consists of street lighting, power required for the water supply and drainage systems. The street light load is practically constant throughout the hours of the night. For water supply, water is pumped to the overhead tanks by pumps. The period usually occur during the night. This helps to improve the load factor of the power system. So, the municipal load is most of the time is being utilized during evening time or the night time. The irrigation load. This type of the load is the electrical power needed for pumps driven by the motors to supply water to the fields. Generally, this type of load is supplied for 12 hours during night. The traction load. This type of load includes tram, cars, trolley, buses, railways, etc. This class of load has a wide variation during the morning hour. It reaches to the peak value because people have to go to their workplace. After morning hours, the load starts decreasing and again rise during evening, since the people start coming to their homes. So, in this way, these 6 main types of the load we must know when we are studying the load curve and the load duration curve. So, friends, this is the study about the load curves, load duration curves and the load factors. In next video, we are going to see some of the numericals based on these concepts. That's all for this lecture. Please feel free to ask any doubts or the questions regarding with it. Thank you very much. Have a nice day.